So in this session I am going to explain the remaining topics of the final drives of Unit 1 in the course Forum Tractors and Construction Equipments of 5th semester Automobile Engineering. Okay. In the last session we have covered introduction to final drive, different types of final drive reductions, and then single reduction final drive. In this session I am going to explain double reduction final drive and double speed double reduction final drive. Double reduction final drive. This double reduction final drive is used in tractors. In this diagram you can see this diagram. This is crown, this is the drive pinion, and this one is the crown wheel, this is the helical pinion, and this one is the helical gear. So as the name itself implies, with the double reduction final drive, the gear reduction takes place in two instances, that is one at the crown and pinion and other at the set of helical gears. This crown wheel is attached to a stub shaft. This helical pinion is the integral part of the stub shaft, to which an helical gear is in mesh. This helical gear is attached to the differential cage. This differential cage unit, this is the differential unit inside this cage, to which two half shafts are splinted. This is the right half shaft splinted here to the sun gear, and this is the left half shaft splinted here to the sun gear. Already you know that differential function as well as the function of this final drive. So here the double reduction takes place twice. That is why it is called as double reduction final drive. What is the necessity of double reduction? By double reduction we will get more gear ratio. So as the gear ratio increases, we are going to get more torque. More torque means it produces more tractive effort. We know that the tractor is the name derived from two words, traction and motor. Traction. What is traction? Traction is the ability of road wheels to transmit the tractive effort without any slippage. So tractors are very much required this tractive effort, because tractors are foreign machinery, so they have to do various kinds of agriculture work in the fields. They have to overcome a large amount of resistance. That's why in order to overcome such a high resistance, high tractive effort is required. In order to get such a high tractive effort, we need high gear reduction. That's why the very lower speed of the tractor is from 2.5 kilometer per hour, and maximum speed may be up to 35 kilometer per hour or slightly 40 kilometer per hour. So at such a slow speed tractor is running while it is doing agricultural process in the farms. That's why in order to get such a heavy torque at the road wheels, it is very essential to go for higher gear ratios. It is not possible to get such a higher gear ratio by using the gear reduction at one stage. Of course it is possible, but at that time we have to use a larger ring gear. Larger ring gear means the diameter of the ring gear or crown wheel is very large, very high. So due to that, what happens? The ground clearance of the tractor will be decreased. So it is one of the disadvantage if we use a large gear of single reduction. In tractors we need high ground clearance because it has to move in the field, and with the single reduction final drive there will be more stress on the teeth of the crown and pinion. That's why in tractors we are using double reduction final drive, one reduction at the crown and pinion, and another one is with a set of gears. So that's why we are getting a large gear reduction and more torque. So here I explained advantages of the double reduction final drive. It provides more ground clearance and then more tractive effort at the road wheels, and it reduces the stress on the teeth of crown and pinion. Here you can see these shafts are mounted with tapered roller bearings. You can see here tapered roller bearings. These tapered roller bearings are radial thrust bearings because this hypoid gear and this helical gears, they exert both radial force and axial force. That's why in order to take off such radial force and axial force, we are using radial thrust bearings. Next, before going to calculate gear ratio, you can see here this crown wheel, this is drive pinion. This drive pinion is the driving gear, ring gear is the driven gear. Again, in this set of gears, helical pinion is the driving gear and this helical gear is the driven gear. So two pinions are driving gears, ring gear and helical gear are the driven gears. So notations are explained here. TP the torque at the propeller shaft, NP the speed of propeller shaft, ZP the number of teeth on drive pinion, ZR the number of teeth on crown wheel, Z1 and Z2 are the teeth on pinion and helical gears. So here calculations, gear ratio YF equals ZR by ZP into Z2 by Z1. ZR and Z2 are the teeth on ring gear and this helical gear respectively. These two gears are driven gears. Teeth on driven gears divided by teeth on driving gears, that is equal to speed of driving shaft divided by speed of driven shaft or wheels. So by this relationship we get speed of road wheels equals speed of propeller shaft divided by gear ratio, and then that means the speed decreases at the road wheels, and then torque at the road wheel equals gear ratio into torque at the propeller shaft. That means torque is multiplied by that gear ratio. Next one is double speed, double reduction, final drive. This double speed, double reduction, final drive. In this case, you can find there are two sets of gears in addition to crown and pinion. Here also this is the drive pinion from the propeller shaft, and this is the crown wheel. This crown wheel carries stub shaft, and this stub shaft, two helical pinions are mounted and they are revolving freely in the fixed positions on their bushes. In between them, a dog clutch mechanism is provided. And then these two helical pinions are in mesh with two sets of helical gears. These two helical gears are mounted on the differential cage. Half shafts are extended on either side of this differential cage. That is not shown in this diagram. And here you can see that, you can remember here that it resembles the main shaft of constant mesh gearbox. So same as like that, here also these two gears are freely revolving. In between that dog clutch mechanism, this dog clutch hub is splintered to the stub shaft, and there is a sleeve. This shifting fork on this sleeve is connected to the hand lever in the driver's cabin through a suitable linkage. So in this case, driver has to shift the gear. When he shifts this fork to left side, then this pinion of somewhat larger size will be engaged with the stub shaft. It will be locked to the stub shaft, but this one is freely revolving. Then power is transmitted from pinion to crown wheel, from crown wheels to stub shaft, from stub shaft to dog clutch, from dog clutch to this pinion, helical pinion, and then to the corresponding helical gear. From this helical gear, power is transmitted to differential cage and half shafts, and then to the wheels. Similarly, when the driver shifts the hand gear lever, then this fork is shifted to the right side, and then it engages with this right side helical pinion. Then the power is transmitted from crown pinion and crown wheel to this second helical gear, from second helical gear to corresponding second helical pinion to corresponding helical gear. Then power is transmitted to this helical gear, and then from this one to half shafts. So like that, here also double reduction, but we are going to get two sets of speeds. Suppose if this is the low gear shifting arrangement, low gear position. If the shifting fork is shifted to left side, then that gear lever is in low speed position, and if the shifting fork is shifted to right side, then the gear lever is in high speed position. So with this arrangement, if the main gearbox has 4 forward speeds, then in the low speed position of this gear lever, you are going to get 4 speeds, 1 2 3 4. And if the driver shift the gear to gear lever to a high speed position, then you are going to get another set of 4 speeds. Like that, with the same gearbox, it is possible to get 8 speeds. That's why it is called as double speed, double reduction final drive. Here you can see that, as usual, this is the pinion is driving, crown is driven. Again these two are driving gears and these two are driven gears. Power is to be transmitted through any one set depending on the position of the shifting fork. According to that we can calculate the gear ratios. So these are the notations. Gear ratio IF1 is given by ZR by ZP into Z2 by Z1, teeth on driven gears divided by teeth on driving gears. That is equal to speed of driving shaft divided by speed of driven shaft. This is NW1 means first set speed in the first set, that is NW1 equals speed of propeller shaft divided by IF1. This is one set of gear ratio. By this we will get the decreased speed of road wheels. Similarly we are going to get increased torque at the road wheels. And again when the driver shift the gear lever to high speed position, again we are going to get second set of speeds and we are going to get second set of torque. Okay. Next, multiple choice questions. The tapered roller bearings are radial thrust bearings because they are subjected to radial force as well as axial force. Why tapered roller bearings are used in automotive as well? This is also same question, same type of question. They take up both axial and radial loads. The tractive effort is the force available at the road wheels. It is not the force at the gearbox or crankshaft or propeller shaft. It is the force available at the road wheels. The hypoid gear final drive changes the direction of rotation through 90 degree. The differential allows the outer wheels to rotate faster than the inner wheels. Outer wheels to rotate faster because this is a function of differential. It allows the outer wheel to rotate faster and inner wheels to rotate slower. Next, 11th one, double reduction axles multiplies the torque. Double reduction axle. Then double reduction means gear reduction. When the gear reduction takes place, naturally torque will be increased at the road wheels. Next, double speed double reduction axles provides dash number of speeds with a 4-speed gearbox. Then it provides 4 into 2, 8 speeds. Thank you.